Hello viewers, in today's session we are going to discuss two important problems from integration, and here we have to evaluate these two integrals with the help of the concept of beta and gamma functions, right? So let us solve these integrals one by one. So let us first consider this integral, and let us call this integral as I, right? So here we'll solve this integral with the help of beta and gamma functions. So let us start with the method of substitution, right? So the method of substitution reduces this integral into the beta function, which is defined as beta m comma n, that is equal to the integral 0 to infinity, and we have t raised to m minus 1 divided by 1 plus t raised to m plus n and dt, right, where m and n are greater than 0. So here we'll first reduce this integral into the beta function, and let us first take x square is equal to t, right? So x can be written as square root of t. Let us differentiate x with respect to t. So we have dx over dt is equal to the derivative of square root of t, and the derivative of square root of t is 1 over 2 times square root of t. So now we can write dx is equal to dt, and here we have 2 times square root of t. So now let us change the limit. So here x varies from 0 to infinity. So when x is equal to 0, then the value of t can be obtained from this equation or this relation. So t is equal to 0 square, that is equal to 0. And when x tends to infinity, then from this relation we can see that t also tends to infinity. So when x changes from 0 to infinity, t also varies from 0 to infinity, right? So the limits remains the same. So now this integral I can be written in terms of t. So we have 0 to infinity, and x square can be replaced by t, and then we have 1 plus t raised to 2, and for dx we can write dt divided by, here we have 2 times the square root of t. So now let us rearrange the terms. So we can take half outside the integral, and we have 0 to infinity. Here we have t raised to 1, and here we have t raised to half. So we can take t raised to half to the numerators, and applying the laws of exponents we can write 1 minus half, and here we have 1 plus t raised to 2 and dt. So let us write it like this, that is 0 to infinity, and t raised to 1 minus half is half, right? And here we have 1 plus t square, and here we have dt. So now this integral is reduced to this one along with this factor half, right? So now if we compare this integral with this one, then we can see that here we have half, and here we have m minus 1. So we can write m minus 1 is equal to half, and here we have 2, and here we have m plus n. So m plus n can be equated to 2, right? Because we wish to express this integral like this. So we can solve these two integrals for these two equations for m and n. So m is 1 plus half, that is 3 by 2, and from here n is 2 minus m. So this is 2 minus 3 by 2, that is 4 minus 3, that is half, right? So now we can write this integral as half, and 0 to infinity, and t raised to half can be written as m minus 1. M is 3 by 2. So here we have 3 by 2 and minus 1, and then we can write 1 plus t, and here we have 2. So 2 can be written as m plus n. M is 3 by 2 and n is half, right? Okay, so now this integral is exactly of this form. So we can now write it as half, and beta function, that is beta m comma n. M is 3 by 2 and n is half. So now we have to find out the value of this beta function using the relationship between beta function and gamma function. So beta m comma n is related to gamma function as gamma m. Then we have gamma n, and then we have gamma m plus n. So here we have half. We can write gamma 3 by 2. Then we have gamma half, and here we have gamma 3 by 2 plus half, that is m plus n, and m plus n is 2. So here we can write 2. So now the integral I is equal to half, and gamma 3 by 2. The value of gamma 3 by 2 can be written as gamma half plus 1. So we can split 3 by 2 like this, half plus 1. So we have half times gamma half, right? Using this result, that is gamma n plus 1 is equal to n times gamma n. So now gamma half is equal to square root of pi. So now we can write half, and here gamma 3 by 2 is half times square root of pi, because gamma 3 by 2 is half times gamma half, that is half root pi, right? And gamma half is square root of pi, and in the denominator we have gamma 2. Gamma 2 can be written as gamma 1 plus 1, that is 1 factorial, that is equal to 1, right? Because we know that gamma n plus 1 is equal to n factorial, where n is some positive integer, right? So here we have 1. So this is half times half is 1 over 4, and here root pi times root pi is pi, right? So we have pi over 4. So the value of this integral I is equal to pi divided by 4. So now let us consider the second problem. So here let us take this integral as I, right? And here also we'll start with the method of substitution, right? And then we'll convert this integral into this form. So let us substitute here. T is equal to x raised to 6, right? So x can be written as the sixth root of t, that is 1 or t raised to 1 over 6. Now let us differentiate x with respect to t. So we have dx over dt is equal to d by dt of t raised to 1 over 6, and applying the power rule, that is the derivative of t raised to n is n times t raised to n minus 1. So here the value of n is 1 over 6. So we have 1 over 6 t raised to 1 over 6 minus 1, that is 1 over 6 t raised to 1 minus 6 over 6, that is 1 over 6 t raised to minus 5 over 6. So now we can write dx is equal to 1 over 6 t raised to minus 5 over 6, and here we have dt, right? Okay, so now let us change the limits accordingly. Here x varies from 0 to infinity. The lower limit is 0, the upper limit is infinity, right? So when x is equal to 0, then the value of t is given by this relation, that is 0 raised to 6, that is 0. And when x tends to infinity, then from this relation we can easily conclude that t also tends to infinity, right? So when x varies from 0 to infinity, t also varies from 0 to infinity. So in this case also the limits remains the same. So now let us write this integral I in terms of t. So we have 0 to infinity, then we have x raised to 4, right? So here x is t raised to 1 over 6. So we have t raised to 1 over 6, and then we have 4 here, and x raised to 6 can be written as t, and this is t plus 1. And for dx we can write 1 over 6 and t raised to minus 5 over 6, and here we have dt. So now let us rearrange the terms, and taking 1 over 6 outside the integral. So we have 1 over 6, 0 to infinity, and here we have 4 over 6, right? And here we have t raised to minus 5 over 6. So applying the laws of exponents, we have t raised to 4 over 6 minus 5 over 6, and in the denominator we have simply 1 plus t, and 1 plus t can be written as 1 plus t raised to 1, and here we have dt. So now we can write 1 over 6, 0 to infinity, and here 4 minus 5 is minus 1. So we have t raised to minus 1 over 6, and here we have 1 plus t raised to 1 and dt, right? So following the same steps which we have done in evaluating the first integral, let us compare this integral with this one. So here we have minus 1 over 6, here we have m minus 1. So we can now write m minus 1 is equal to minus 1 over 6, and m plus n is equal to 1, right? So from here m is 1 minus 1 over 6, that is 6 minus 1 over 6, that is 5 over 6, and the value of n is 1 minus m, that is 1 minus 5 over 6, that is 6 minus 5 over 6, that is 1 over 6, right? So now we can write this integral I as 1 over 6. We have 0 to infinity, and t raised to minus 1 over 6 is m minus 1, and m is 5 over 6. So we can write 5 over 6 minus 1. Here we have dt, and 1 plus t raised to 1. 1 is m plus n, right? M is 5 over 6, and n is 1 over 6. So 5 over 6 minus 1 is minus 1 over 6, and 5 over 6 plus 1 over 6 is equal to 6 over 6, that is 1, right? So this integral is now exactly similar to this one. So we can now write 1 over 6, and we have the beta function, that is beta m comma n. M is 5 over 6, and n is 1 over 6. So let us now calculate the value of this expression. So using the relationship between beta function and gamma function, we have gamma 5 over 6, then we have gamma 1 over 6, and here we have gamma 5 over 6 plus 1 over 6, right? So now I can be written as 1 over 6, gamma 5 over 6, gamma 1 over 6, and in the denominator we have gamma 5 over 6 plus 1 over 6 is simply 1, gamma 1 is 1, right? So in the denominator we have 1, and now to evaluate this expression we have to make use of Euler's reflection formula. So now Euler's reflection formula goes like this, that is gamma 1 minus n times gamma n is equal to pi divided by sine n pi, right? And if we take n is equal to 1 over 6 in this result, then we have gamma 1 minus 1 over 6, and then we have gamma 1 over 6, and that is equal to pi divided by sine pi over 6. So gamma 1 minus 1 over 6 is gamma 6 minus 1, that is 5. So we have 5 over 6, then we have gamma 1 over 6, and this is equal to pi divided by sine pi by 6. Now sine pi by 6 is sine 30 degrees, that is equal to half, right? So here we have half, taking this half to the numerator, we have 2 pi. So this product, that is gamma 5 over 6 times gamma 1 over 6 is 2 pi. So let us substitute this value over here. So we have I is equal to 1 over 6 times 2 pi, and here 2 times 3 is 6. So we have pi over 3. So the value of this integral I is equal to pi over 3, that is pi divided by 3. So viewers, this is how by the application of beta and gamma functions we can easily evaluate these kind of integrals. Hello viewers, in today's session we have another important and interesting problem from beta gamma functions, and here we are going to evaluate this integral that is from 0 to 2 x raised to 5 over 2 divided by square root of 2 minus x dx with the help of some concepts from beta and gamma functions, right? So let us start. So let us first take this integral as I, right? Now here what we will do, will first make use of the method of substitution, right? And by using the method of substitution, we'll convert this integral into this form, that is the beta function, that is beta m comma n is given by the integral 0 to 1 t raised to m minus 1 and 1 minus t raised to n minus 1 dt, where m and n are greater than 0. So here we'll substitute x is equal to 2 times t, right? And using this substitution we'll convert this integral into this form. So here x is equal to 2t, and t can be written as x over 2. Now let us differentiate x with respect to t. So we have dx over dt is equal to d by dt of 2t, and then we can write 2 times d by dt of t, and the derivative of t with respect to t is 1. So we have 2 times 1, that is equal to 2. So now we can write dx is equal to 2 dt. Okay, so now here we'll change the limits accordingly. So here the lower limit is 0 and the upper limit is 2. So when x is equal to 0, then the value of t can be obtained from this relation. So t is equal to 0 over 2, that is 0. And when we have x is equal to 2, then the value of t can be obtained from again from this relation. So we have 2 over 2, that is 1, right? So now let us write this integral in terms of t. So now we can write the integral I as 0 to 1, and here when x changes from 0 to 2, t goes from 0 to 1, and for x we can write 2t, So we have 2t raised to 5 over 2 divided by square root of 2 minus 2t. And here we have for dx we can write 2 dt. So let us now simplify this expression. So we can now distribute this power, that is 5 over 2 over 2 and t. So we have 2 raised to 5 over 2 t raised to 5 over 2. Here we have 2 raised to 1 and dt, and in the denominator we have square root of 2 times 1 minus t. So taking 2 common in the under the square root sign. So now we can write 0 to 1. We have 2 raised to 5 over 2 and t raised to 5 over 2, and here we have 2 raised to 1, and taking square root of 2 to the numerator, we can write 2 raised to minus half, and here square root of 1 minus t can also be taken to the numerator. So we can now write 1 minus t raised to minus half, and here we have dt. So now let us further simplify it. So here we can collect all these 2's. So we have 2 raised to 5 over 2, then we have plus 1, and then we have minus half, and here we have t raised to 5 over 2 and 1 minus t raised to minus half, and here we have dt. So now simplifying this term, so we have 2 raised to, here we have 5 over 2 minus half is 4 over 2, that is 2, and 2 plus 1 is 3. So we have 2 cube, that is equal to 8, right? And taking 8 outside the integral, we have 8 times 0 to 1 and t raised to 5 over 2 and 1 minus t raised to minus half and dt. So now let us write I is equal to 8 times the integral 0 to 1, and t raised to 5 over 2 can be written as 7 over 2 minus 1, because 7 over 2 minus 1 is equal to 7 minus 2 over 2, that is 5 over 2. And here we have 1 minus t raised to minus half, and minus half can be written as half minus 1, and here we have dt, because half minus 1 is equal to minus half, right? So now we can see that this integral is similar to this one, right? And here if we compare this integral with this one, then here we have 0 to 1, 0 to 1, and t raised to m minus 1. So here we have t raised to 7 over 2 minus 1. So comparing m is equal to 7 over 2, and here we have 1 minus t raised to half minus 1. So here we have 1 minus t raised to n minus 1. So comparing, again comparing, we can now write n is equal to half, right? So now we can write this integral I as 8 times the beta function, that is beta 7 over 2 comma half, right? So now we have to find out the value of this expression by using an important relationship between beta function and gamma function. So beta m comma n is given by gamma m times gamma n divided by gamma m plus n. So here we can now write gamma 7 over 2, then gamma half, and then we have gamma 7 over 2 plus half, right? Okay, so now let us find out the value of gamma 7 over 2. Now gamma 7 over 2 can be written as gamma 5 over 2 plus 1, and here we'll again make use of an important result, that is gamma n plus 1 is given by n times gamma n. So here the value of n is 5 over 2. So we can now write 5 over 2 times gamma of 5 over 2. And again, we can split 5 over 2 as 3 by 2 plus 1. So again, applying this result to this one, so we have 5 over 2 times 3 by 2 and gamma 3 by 2. So let us further write gamma 3 over 2 as half plus 1. So we can now write 5 over 2 times 3 over 2 times half, and then we have gamma half. So here again we have used this result, right? So now this is 5 times 3 is 15, and here 2 times 2 times 2 is 8, and gamma half is given by square root of pi. So now in the denominator we have gamma 7 over 2 plus half. So we have 7 over 2 plus half is 7 plus 1 over 2. That is gamma 7 plus 1 is 8. 8 over 2, that is gamma 4. And gamma 4 is equal to 3 factorial, that is equal to 6, right? Because we know that gamma n plus 1 is equal to n factorial, where n is some positive integer. So now we can write the value of this integral I as 8 times gamma 7 over 2, which is 15 over 8, and here we have root pi, and gamma half is square root of pi, and divided by this expression, and this is equal to 6, right? So now this 8 and this 8 get cancelled, and we have 15 over 6. Root pi times root pi is pi, and again simplifying, this is 3 times 5, and 3 times 2 is 6. So we have 5 pi over 2, right? So viewers, the value of this integral I is 5 pi divided by 2. Hello viewers, in today's session we are going to discuss another important problem from beta and gamma functions, and here we are going to find out the value of this integral using the concept of beta and gamma functions. So we have to evaluate the integral 0 to 1, and we have dx over the sixth root of 1 minus x raised to 6, right? So let us first convert this integral I using the method of substitution to the beta function, which is given by beta m comma n is given by the integral 0 to 1, and we have t raised to m minus 1 minus t raised to n minus 1 dt. So the first step is to convert this integral by method of substitution to this integral, and then we'll apply the properties of beta and gamma functions, right? So let us take this integral as I, and here what we will do, we'll first write this integral I as 0 to 1. We have dx divided by 1 minus x raised to 6 raised to 1 over 6, and let us make this substitution, that is t is equal to x raised to 6, so that we can write x is equal to t raised to 1 over 6. Now let us differentiate x with respect to t. So we can now write dx over dt is equal to d by dt of t raised to 1 over 6. So using the method of power rule, that is the derivative of t raised to n is given by n times t raised to n minus 1. So we have n is equal to 1 over 6. So we have 1 over 6, then t 1 over 6 minus 1. So we have 1 over 6, and t raised to 1 minus 6 over 5, that is 1 over 6 t raised to Here we have 6, and then we can write minus 5 over 6. So now we can write dx is equal to 1 over 6 times t raised to minus 5 over 6, and here we have dt. Now let us change the limits accordingly. So here x varies from 0 to 1. So when x is equal to 0, the value of t can be obtained from this relation. So we have t is equal to 0 raised to 6, that is simply 0. And when t is equal to 1, then we have t is when x is equal to 1, then we have t is equal to 1 raised to 6, that is simply 1. So when x varies from 0 to 1, then t varies from 0 to 1. So now let us write the value of this integral I in terms of t. So we can now write I is equal to 0 to 1, because the limits remains the same, and we have for dx we can write 1 over 6 and t raised to minus 5 over 6 dt, and in the denominator we have 1 minus t, because x raised to 6 is t, and here we have 1 over 6, right? So now taking 1 over 6 outside the integral, we have 0 to 1, and then we have t raised to minus 5 over 6, and taking 1 minus t raised to 1 over 6 to the numerator, we can now write 1 minus t raised to minus 1 over 6, and here we have dt. So now we can easily observe that this integral is similar to this one, that is the beta function, that is beta m comma n is 0 to 1 t raised to m minus 1 1 minus t raised to n minus 1 dt, where m and n are greater than 0. Right, so here we have t raised to minus 5 over 6, and here we have t raised to m minus 1. So now we need to find out the values of m and n. So we can compare this integral with this one. Here we have an additional factor 1 over 6. So now m minus 1 can be written as minus 5 over 6, and n minus 1 can be written as minus 1 over 6. So let us solve these two equations. So we can now write m is equal to minus 5 by 6 plus 1, that is minus 5 plus 6 over 6, that is 1 over 6. So the value of m is 1 over 6, right? And from this equation we can now write n is minus 1 over 6 plus 1. So n is minus 1 plus 6 over 6, that is 5 over 6. So we can now write n is equal to 5 over 6. So now we can write this integral as 1 over 6, 0 to 1, and t raised to minus 5 over 6 is m minus 1. So we have m is equal to 1 over 6. So 1 over 6 minus 1, and here we have 1 minus t raised to minus 1 over 6. So minus 1 over 6 can be written as n minus 1. So we have n 5 over 6, and this is minus 1 and dt. So now this integral is exactly similar to this one. So we can now replace this integral by the beta function. So we have beta m comma n. M is 1 over 6 and n is 5 over 6. So now we have to find out the value of this expression. So to get the value of this expression, we'll make use of an important relation between beta and gamma functions. So gamma beta m comma n is given by gamma m times gamma n divided by gamma m plus n. So now using this relation, we can now write 1 over 6. Then we have gamma 1 over 6 times gamma of 5 over 6 divided by gamma 1 over 6 plus 5 over 6. So now we can write 1 over 6, then this is gamma 1 over 6 and gamma of 5 over 6 divided by 1 over 6 plus 5 over 6 is 6 over 6, that is equal to gamma 1, and gamma 1 is equal to 1. So here we have 1. So now we can write the value of the integral I as 1 over 6 gamma 1 over 6 and gamma 5 over 6. Now to get the value of this expression, we have to make use of the famous Euler's reflection formula. And the reflection formula goes like this: gamma 1 minus n times gamma n is equal to pi divided by sine n pi, right? So if we take this n as 1 over 6, then we have gamma 1 minus 1 over 6, gamma 1 over 6, and here we have pi divided by sine n pi. So n is 1 over 6, so we have pi over 6. So now this is 1 minus 1 over 6, so this is gamma 5 over 6, and here we have gamma 1 over 6, and this is pi divided by sine pi by 6. Now sine pi by 6 is sine 30 degrees, that is equal to half. So here we have half, so this is equal to 2 pi, taking this 2 to the numerator. So the product of gamma 5 over 6 and gamma 1 over 6 is equal to 2 pi. So substituting this value over here, the value of the integral I is now 1 over 6 times 2 pi, and we can now cancel this 6 by 2. So we have here 2 times 3 is 6. So this is pi over 3. So viewers, the value of this integral is equal to pi over 3. So this is how, by making use of the concept of beta and gamma functions, we can easily evaluate integrals of this kind.